Hello students, good morning. So yesterday I have given you the procedure for hypothesis testing. I have given 6 steps for doing hypothesis testing problem. So today we will see a problem. Listen carefully. So this yesterday whatever 6 steps I have given you, the same 6 steps will be using in the problem. So here we have taken a simple problem. I didn't take a descriptive problem. Directly I have taken a small problem and I'll send you the one or two problems later. So here in this problem, here we have directly taken, because this is the first problem, I have taken a direct problem. So he has given h naught mu equal to 15. That means the null hypothesis is 15. That means the null hypothesis, the assumed mean is 15. Now this is your aim which you have to check. For this we are doing the problem. So the null hypothesis is the assumed mean is 15. The mean of the population is 15. And this is directly he has given h1 mu is not equal to 15 and x bar sigma n alpha we have taken. So when the problem is given this way, because this is the first problem, I am doing the direct method problem. That is where they have given the null hypothesis, alternate hypothesis, mean, sigma, that is standard deviation, and sample size with alpha, the significance level alpha. Actually a problem in a descriptive manner will be given where you have to identify what is the null hypothesis, what is alternate hypothesis. You have to mention this way. So one step ahead we are here. So the descriptive problem I will send you. So here this is the yesterday as I gave you in the method, the first step is you have to write the null hypothesis. So that is h naught mu equal to 15. And the second step is you have to write the alternate hypothesis. I have given you the method. We are following the same method yesterday what I have given you. So the first step is you are writing the null hypothesis. Next, alternate hypothesis, whatever he has given. So this is not equal to, yesterday I told you when it is not equal to, you have to take it as a two-tailed test. That means the rejection part will be on both the sides because this is not equal to. So I immediately write what is alpha. In the next step, the third step, you have to draw a graph. Draw a graph. Because here n is 35, that is a big sample, we are taking a normal distribution curve. So this is a normal distribution curve. We are drawing the graph. So see here carefully. So here because it is a two-tailed test, you have rejections on both the sides. So draw this graph with two rejection parts on both the sides. If it is less than or if it is greater than, your rejection part, if it is less, rejection part will be only to the left side, and if it is greater, the rejection part will be only to the right. No two rejections. Because this is a two-tailed test, because of not equal to, we are taking a two-tailed test. That means your rejection parts will be on both the sides. So now whatever alpha they have given you, the significance level, divide it into two parts. So it is 0.025 and 0.025. That means both the sides the rejection 0.05 is being divided. So this comes to 0.025, this is 0.025. So this is the graph what we have drawn. So half part is 0.5, half part is 0.5 in the normal distribution curve. So if 0.025 goes off, that means from 0.5 you have to subtract 0.025. This will be 0.475. So this part that is the leftover part is the acceptance region, that is 0.475, and here 0.475. Total, if you add this and this, it should be 0.5. Rejection plus acceptance should give you 0.5. Here also rejection plus acceptance should give you 0.5. So when the alpha is given, if it is one side, for example, if it is one-tailed test, all 0.05 will be to one side only. The leftover you have to take. But because this is a two-tail, that 0.05 we have divided it into two parts, and this comes to 0.025, 0.025. The leftover is 0.475. And in the normal distribution curve table, Now this is a big sample, so you are using Z table. In the Z table, I already told you how to look after the values in the Z table. So if this is the Z table, in this, inside the table, check where you have this 0.475 approximately, if not exactly the nearing value 0.475. so inside the table you have to check, so where you have this 0.475 nearly, so 0.475 475 here you have 0.4750. I have it here, 0.4750. This is corresponding to 1.9 and on the top 0.06. So it will be 1.9 and this value 6. So at 1.96 the value of Z is 0.475 approximately. So that means this 1.96 is this border value, this line. So this side it will be minus 1.96, here it is plus 1.96. So we have got this Z as 1.96. So next step is find standard error of mean. Standard error of mean, that is sigma x bar is sigma by root n. So find sigma is 3, root n is 35, it is 0.507. So after you get this, the next step is this is Z. You have to find the Z. You call it as standardizing the sample statistic. So standardizing sample statistic, Z is x bar minus mu h naught by sigma x bar. This is the formula. So x bar, the mean is given as 14.8 minus mu h naught. Mu h naught means assumed mean. That is in the null hypothesis, whatever value you have here, this is mu h naught. In the null hypothesis, whatever number you have here, you have to take that divided by 0. Sigma x bar, that is this particular value, whatever we got, 0.507. So next, after that, you have to find you have to simplify. Then I got the value as minus 0.39. So that minus this value is minus 0.39. So now you have to, in the next step, decide whether to accept or reject null hypothesis. So now see here, whatever answer we got here, minus 0.3. In this particular graph, you have to decide. That means from the table I got 1.9. When I calculated, I got this Z as, this is a Z value, minus 0.3. So you have to compare this 0.3 with 1.96. 0.3 is actually less than 1.9. This is from the table, this is from the statistics we have calculated. So this is 0.3. 0.3 means, now compare this with what you have got from the table, 1.9. 1.9 and 0.3. 0.3 is less than 1.9. So that means it falls somewhere before this 1.9. Because this is minus, we go to the negative part. So somewhere here you have this minus 0.3. So that means because this is less than 1.9, this falls in the acceptance region. So because it is in the acceptance region, you accept the null hypothesis. Suppose you got minus 2, for example. If it is minus 2, it is greater than 1.9. So it crosses this 1.9. So it comes into the rejection region. In that case, you reject the null hypothesis. Now because this is less than, your minus 0.3 is less than 1.96 plus or minus, because it is minus, we take minus. So it is less than 1.96, it is in the acceptance region. So we accept the null hypothesis, accept H naught, and reject alternate hypothesis. So if it is in the rejection region, you reject null hypothesis and we accept alternate hypothesis. So in that case, you are accepting alternate hypothesis. So this is the method for your hypothesis testing, and same method problem you will be doing from now. So be careful and follow it properly.